In the Karakum Desert, a hole in the ground has been burning non-stop for more than 50 years, and nobody actually planned for that to happen. It started as a mistake, one Soviet drilling accident, and it turned into one of the strangest fires ever lit by human hands. Rewind to 1971. Soviet geologists are drilling for natural gas deep in the Turkmen Desert, hunting for a reserve worth exploiting. Their rig strikes something unexpected, a massive underground cavern, and the ground beneath the drilling site simply gives way, collapses. The collapse opens a crater 70 meters wide, venting flammable methane gas straight into the open desert air around the site. Worried about poisonous gas spreading toward nearby villages, the geologists make a fateful call: set the leaking methane on fire. Their plan is simple: burn off the gas in a few days, then walk away and let the crater go quiet forever. Weeks pass and the fire keeps burning, fed by a reserve far larger than anyone drilling that day ever imagined underground. Years turn into decades, and the flames never stop, earning the crater a new nickname. Locals start calling it the door to hell. By the 2020s, the fire has been burning continuously for over 50 years, visible for miles across the flat desert night. A modern engineering team sets up camp near the crater, determined to finally understand what is actually happening underground here. Inside their tent, banks of sensors track gas flow, temperature, and pressure, reading data no one collected back in 1971. Out at the rim, an engineer holds a gas meter over the flames, measuring exactly how much methane the crater still burns. The readings are staggering. The crater still vents enough natural gas to raise real concerns about wasted energy and climate impact. Back at camp, the team debates the numbers. Methane is a far more potent greenhouse gas than the carbon dioxide it becomes. Viewing months of sensor data, the engineers conclude the fire cannot simply be left burning forever without real environmental consequences. Meanwhile, the crater keeps blazing exactly as it has for half a century, indifferent to every meeting happening a few hundred meters away. The team's solution is not to smother the crater directly, but to drill a new well that redirects gas around it. Workers assemble a bypass wellhead nearby, a modern valve system engineered to intercept methane before it ever reaches the burning pit. Progress gets tracked week by week, as the new well slowly starts pulling pressure away from the crater's original gas source. For the first time in decades, observers at the rim notice something new: a handful of the flames actually shrinking in size. Seen from above, the crater's usual solid ring of fire now shows visible gaps, dark patches where flames used to burn constantly. At the bypass site, the engineer turns a heavy control valve, redirecting even more of the underground gas away from the crater. Back at the crater that night, the change is obvious. The once blinding blaze has dropped to a noticeably smaller, dimmer glow. Sensor readings confirm it. Methane emissions from the site have measurably dropped since the bypass well went into full operation. What used to be a churning wall of fire now flickers as scattered embers, a fraction of the inferno it once was. Back at camp, the engineer allows herself real optimism. A fire that outlived the Soviet Union might finally be nearing its end. From overhead, the crater that once glowed like a small sun now reads as mostly dark. Just a few stubborn hotspots left. 54 years after one drilling accident lit it by mistake, the door to hell is, for the first time, actually closing. One collapsed drill site, one panicked decision, and half a century later, humans are still trying to finish putting out that fire.